Imagine a world where we were less dependent on foreign sources of energy and we produce less greenhouse gas emissions. No simple answer exists today, but it is clear that global demand for energy will continue to grow and prices will continue to rise. One way to offset the rising cost is to reduce our demand of gas and electricity by installing highly efficient equipment for domestic hot water and home heating applications. HTP is pleased to introduce one of the most exciting new products to ever be introduced to the domestic hot water and home heating markets. The new Versa Hydro offers our customers an all-in-one appliance that produces hot water for domestic and home heating applications in one elegant and simple to install appliance. The Versa Hydro saves money on the installation and consumes less energy because it utilizes technology that makes it both highly combustion and thermal efficient. Because the Versa Hydro is a combined appliance, it saves considerable space over traditional domestic hot water and home heating installations. The most amazing part of the appliance is how it performs. This product consumes less gas, produces less emissions, and is virtually maintenance-free. Now sit back and take a virtual tour with Heat Transfer Products owner and CEO, Mr. Dave Davis, at this year's 2010 AHRI show.
Show 2010. This is where we do our solar connections, and we can hook up to a panel to provide solar energy into the tank, which is integrated. Second component is the domestic connections, where we have our return and supply ports, where we service to domestic hot water needs, whether it be a shower, whether it be jacuzzis, whatever it might be. And we're drawing the water directly from the storage tank. Third component is essentially the heating module, which basically allows you to connect up to your central heating system, and whether that be radiant, whether it be air handlers, baseboard, this provides the central heating needs for the system. And then the fourth component is where we have a couple auxiliary taps, where those can be hooked up directly to an air handler. So this could be servicing the radiant, the auxiliary ports could be hooked up directly to an air handler. You have your hot water connections, and then the first one I talked about is the solar connection. So this tank does a lot of stuff for you. It integrates a lot of components, and the most important part about it is that everything that we've devised here, with the way the controls work, with the way the system works, is for efficiency. We always try to maintain the lowest set point based on your designs, based on how you apply it in the field, in order to optimize the efficiency of the system and the multiple connections you have and the capabilities you have with the system. It's an extremely unique product out there. Essentially what we did is we took a high efficiency gas-fired water heater and we incorporated what we call our heating module. The heating module is essentially a boiler. And what the heating module essentially does is take the heated water stored in the tank and basically backfeed it through this brazed plate. And what we're doing is we're creating central heat, and what we're doing is we're supplying domestic water, which is stored in the tank, and then we're backfeeding the system and basically utilizing the heated domestic water to heat the central heating loop through these supply and return connections. The beautiful part about this is it's an integrated system. You have one tank that provides thermal storage, basically gives you hydraulic stabilization, and in one simple package. Another nice feature about the system is that with system loads, we can basically modulate the pump to achieve actual system load balancing with the central heating in order to accommodate small zones or other things that can create short cycling normally with conventional systems. One of the things I want to show you with the tank design as I went through it, is showing you the inside of the tank. Essentially, here's our combustion system, where we have our Cooper-Nickel exchanger, where we take the heated gases and we condense them, and we transfer that energy into the tank. And then we have our distribution tubes, which basically take the water from the top of the tank, and then after it goes through the brazed plate on the front of the heating module, we dissipate the heat on the bottom and bringing the cold water back into the structure, into the inside of the tank. One of the nice things about this tank, again, is that everything is integrated. It's high efficiency. We have sensors inside the tank which allow us to change the tank's set point temperature based on what's happening outside. So as the temperature starts to get colder outside, we increase the set point in order to satisfy the central heating demand through the brazed plate exchanger. One other feature I want to point out is in this tank here, this tank is actually our solar tank, where we basically have a bivalent design where we have two sections of the tank. We're only heating the top quadrant to maintain a particular set point if the sun's energy is not giving us enough energy in our bottom heat exchanger, where we connect up the solar panel. Essentially, this is an integrated system that can not only take the sun's energy and supply domestic hot water, but it also can backfeed the heat loop through the heating module. So this is a totally integrated system where you have one tank that can provide 96% combustion efficiency on the gas side backup. It can provide solar energy through the highly efficient heat exchanger, which is located on the bottom, which can be connected to your solar panels. And the third component is it has a heating module in it, where it can take the solar energy or the backup gas energy and essentially backfeed that into your system. So essentially, if you think about it, we have a system that's, when it's just operating on gas, is 96% efficiency. But when you start taking the solar component to it, your efficiencies are going to be over 100%, because you're going to be taking free energy from the sun and then preheating that inside the tank itself.